So today marks the end of the second week, so we're halfway there. So I'm going to share with you guys today's work. So first things first, I need you guys to answer these survey questions for the 3C students because they do have an assignment that they need answers for. So if you could do that right away, send me your answers right away through email or Dropbox. Don't wait to do the rest of the stuff. Just get that done, send it to me, and then do the rest, please. The earlier that we can get that in, the earlier they can start their assignment. So we're looking at graphing transformations today, and then I'm just going to go over assignment number 3 real quick. So I do have one survey question so far. So yesterday we looked at transformations, and kind of can think of it as like Tetris almost. So every number and their position in the function plays a role. So for example, if you had the coordinate point x, y, it would become 1 over k x plus p would be our x, our new coordinate for x. And then ay plus q gives us our new y coordinate. I've never really thought of it that way. I've always just moved all of the points over wherever they need to go. Yeah. So when graphing the order of transformations is as follows. I think of it just as going from left to right, but we would do the P first, the K, and then the base function, and then your A and your Q. Yeah. Okay, so we're going to look at example 1. So given the function f of x is x squared, find where the point 525 would be translated into this function. Okay, so I'm just going to display that point at the top there for you guys. So what you're doing here, oops, this is your x and this is your y. So for your new point, you would have 1 over k. So your k in this function is our 5. So this is k. This is a, p, and q. And I circled the sign there because the sign makes a difference with the q. So 1 over k would be 1 over 5 times x, which is 5, plus p, which is 3. So our new x would be 1 plus 3, which is 4. So our new point there would be 4. So that's our x value, our new one. And then for our y, we do a, which is 2, times 25, which is 50, minus 4, which is 46. Okay, so our new point would be 446. Okay. So I'm going to clear this. Okay, so what are the values of A, K, P, and Q in our new function? So we have y is equal to 5f 3x minus 6 plus 2. So our A would be 5. So this number here is our A. Our K is the number in front of the X. So K is 3. P would be our 6. And Q would be 2. Okay. So given the following function, you have to graph these guys. So like we've seen before, this means that it goes up 2. So when we have our +2 here, all of our points go up 2. So you take this point, I probably shouldn't use blue for this guy. Okay, so this will go up by 2. This will go up by 2. So you take all of your original points and you move them up by 2. Okay, and then you redraw it with straight lines because you guys have rulers and I don't. Okay, so that's our first one. Now for our second one, we have 2f of x. Okay, that means that all of our y values are going to be multiplied by 2. So that means that -5, it's still going to stay there. Here we have 5, but it's going to move up to 10 because it's being multiplied by 2. Same with this guy. This is -1. So -1 times 2 is -2. And then this is 1/2. So times 2 just becomes 1. So our graph will look like this. So remember yesterday when I said if there's a number above 1 in front of f of x, that it stretches vertically. So that is a stretch vertically. Okay. Our next one we have, so this is inside the bracket, and don't let that sign confuse you. It's going to be the opposite. So this means that it's moving to the right. To the right by 3. Okay, so again, you're going to take your original points and it's going to move over to the right by 3. So this one goes there. 1, 2, 3. That one goes there. 1, 2, 3. 1, 2, 3. So it's off the graph over here. And again, straight lines with a nice ruler, which I wish I could use right now. Goes like that. If we look at number 4, okay, so they should all have the same shape. It's not going to go into a straight line or anything. The whole thing is just shifting over and moving. So this one is going to move to the left by 1 and up by 2. So up by 2 because of here. Okay, still shouldn't be using blue. Okay, so we're going to use, we'll do pink. Okay, so it's going to the left by 1, up by 2. Left by 1, up by 2. Left by 1, up by 2. So like that. Okay, so your graph will often look a little messy like this. Make sure to color code it and take the steps necessary. I'm going to clear this and we'll move on. Oh no, that was it. So for the independent questions, number 1, what transformations would you need? So you're going to say if it stretches, it compresses vertically or horizontally. If it moves to the left, to the right, up, down, etc. This you're going to have to sketch them onto a graph. You can do it on Desmos if you need. I'd rather you do it on, you can get graph paper or line paper and do it from there. Explain what transformations you need to apply to the graph for each function. So the same thing, does it stretch, compress, move to the right, move to the left, up, down, etc. We're going to sketch these out. So this is the original one, and then what it would look like. Okay, and so on. So the same thing. Don't worry about number 8. You guys didn't learn the graph for that one. And that's it. So then you have your assignment. So your assignment, you have to describe the transformations that you're doing. So again, is it a horizontal or vertical stretch or compression? Is it left? Is it right? Is it up? Is it down? When you tell me if it's a stretch or compression, make sure to tell me if it's horizontal or vertical. And then your negative means that it's flipped. So it's upside down. Okay, so you've got a few of those, and then you've got 3 of these where you have to tell me the transformation. So the same thing that we just talked about. Create a table of values and then draw it on here, what it would look like. So you've got 3 of those. And that is